Alright, in this video we're going to be solving some past paper questions of permutations and combinations. As you know, recently I put up a post on my Instagram where I asked you guys to send in questions for me to solve for this video, and you guys did. So I'm going to be solving the questions that you guys sent. So we start off with a question which is from May-June 2005. May-June 2015, yeah, paper 1, variant 2. And this is question number 5. Okay, so let's get straight to it. So it says the security code is to be chosen using 6 of the following: the letters A, B, and C, the numbers 2, 3, and 5, and the symbols asterisk and dollar. Okay, I'm just going to call it star. Okay, none of the above may be used more than once. So as you know, I like to highlight what I think is important. Okay, so this I feel is important, so I'm going to highlight it. Find the number of different security codes that may be chosen if there are no restrictions. Okay, so when there are no restrictions, it's the easiest thing to do. So let's see what is the total quantity of elements that we have to choose from. Okay, so we have 3 letters A, B, and C. Okay, we have 3 numbers, so that's 2, 3, 5. So 3 and 3 is 6, and we have 2 symbols. So that means altogether we have 8 to choose from. Okay, and the security code that we're going to make is going to be use 6 of the following. Okay, now there's one thing that you should understand over here. Suppose to unlock someone's phone, suppose the passcode to someone's phone or to your phone, let's say, is 1, 2, 3, 4. Okay, but suppose someone were to enter 4, 3, 2, 1. Now, although it's the same elements, okay, but that's not going to work. Okay, reason for that is that when you're setting up a code, the order is important. So the reason why I'm discussing this here is because I need to decide what to use here. Okay, and since we're making a code, so code is where order is important. Okay, you may have the same elements, but if you don't have them in the right order, it's not going to work. Okay, so that means I'm going to be using permutation since order is important. So we have a total of 8 to choose from, and 6 are the and we're going to be choosing 6, but again we're going to choose them and also arrange them. Okay, so that means, in short, I'm going to be using permutation. So the answer to the very first part is pretty simple. It's going to be 8p6. It's a no-brainer. 8p6 is equal to 20160. So 20,160. That means you can make a total of 20,160 codes if there are no restrictions. Okay, the security code starts with a letter and finishes with a symbol. Okay, so at this point what I'd like to do is let's add a bit of more detail to this. So let's make 6 blanks: 1, 2, 3, 4, 5, and 6. Oh, sorry about that again. Yeah, so if it starts with a letter, so that means for the first place we have 3 options, and they are A, B, and C. So I'm going to write 3 here. Okay, and ends with a symbol, so that means for the last place we have 2 options, and they are star and dollar. So that means for the last place we have how many options? We have 2 options. Now for the remaining, wait, 1, 2, 3, 4, 5. Sorry, I was supposed to make 6, just realized. Anyway, nothing to worry about. Okay, so now we have 1, 2, 3, 4, 5, 6. Okay, now for the remaining 4 places, there's nothing that we need to worry about. So that means we initially had 8 to choose from. Now 2 of them are gone, so that means we're left with 6, and we need to arrange 4 out of the 6 remaining. So for the elements in between, we're going to do 6p4. So here's how this works: 3 times 6p4 times 2. So let's work this out in our calculator. 3 times 6p4 times 2. So that gives us 2,160. Now remember, whenever there's a condition or a restriction, that restriction needs to be settled first. So here there was a restriction, and that was that it needs to start with a letter. So you can see that I've settled that first, and it needs to end or finish with a symbol. So that's what I settled later on, and then you can worry about the rest. Okay, now here comes part 3, which says that the 2 symbols are next to each other in the security code. Okay, so let's go back and make 6 blanks again. So 1, 2, 3, 4, 5, and 6. Okay, now when it says that the 2 symbols are next to each other in the security code, it doesn't really specify where the symbols need to be. So that means it can be the first 2, it can be the second and third, the third and fourth, the fourth and fifth, just like that. Okay, so here's how this works. So I'm going to make a box. Okay, and I'm going to assume that the 2 symbols are inside that box, and the symbols can shuffle themselves to factorial number of ways. Okay, like how many symbols do we have? We have star and dollar, right? So that means it could be star and then dollar, and dollar and then star. Okay, now Next is, now this is where it gets important. So out of the 8, 2 are gone, so that means how many are we left with? We're left with 6. So that means for the remaining 4 we have 6 to choose from, so we're going to do 6p4. And again, the reason why we're using permutation is because order is important. But this doesn't end here. Now I'll show you why that is. So basically what's important for us to understand here is that, like I mentioned in the beginning, it's not important that the symbols need to be the first 2 elements. Okay, so that means one possible arrangement is when they are indeed the first 2 elements, and another possible arrangement is when they can be the second 2. Okay, so that's number 2. And then there's another arrangement. In fact, let's see how many possible arrangements there are. So one arrangement would be, let's move this from here and let's drag this, and they could be the 3rd and 4th. Okay, and you can probably see where this is going. Next, they could be the 4th and 5th, and then they could be the 5th and 6th. So in short, all of this was practically unnecessary. So here's what I should have done at the very beginning. 2 factorial into 6p4 times the number of ways this can be arranged. Okay, so how do we figure that out? Let's see how many independent blocks we have. Yeah, how many independent spaces do we have? So here's 1 unit. Okay, so 1, 2, 3, 4, 5. So that means 2 factorial times 6p4 times 5. So that will give you the total number of arrangements that you can have such that the 2 symbols are next to each other. So 2 times 6p4 times 5, and that is equal to 3600. Okay, so all of this was just to give you an idea what exactly is going on, but when you're solving a question, it's not absolutely necessary to show all this. Okay, you can just simply multiply it by 5, since that are the number of ways this data can be arranged. Okay, now we move to part B of the same question, and it says 2 teams. Okay, so the word 2 is very important. Each of 4 students are to be selected from a class of 8 boys and 6 girls. Find the number of different ways the 2 teams may be selected if there are no restrictions. Okay, so if there are no restrictions, then this shouldn't be too difficult. By the way, I'm going to be using combination here. Why? Because we're selecting team. Okay, whenever you're selecting a team such that the merit is not defined, so what do you use? You use combination. So you have a total of 14 people to choose from, and how many are you choosing? You're choosing 4. So 14C4 for the first team. Okay, now remember, you're making 2 teams. Now out of 14, 4 have already been selected, so that means now you have 10 to choose from. And again, since you're selecting 2 teams of 4, that means even for the next team, you're going to be choosing 4 people. So 10C4. So 14C4 times 10C4 gives us 210,210. 210, and that is the correct answer. Okay, now here's part 2. Part 2 says one team is to contain boys only and the other team is to contain girls only. Okay, so let's go back to the data that's provided to us. So you have 8 boys and 6 girls. So that means one team should have all 4 boys and the other team should have all 4 girls. So how many boys do we have? We have 8 boys. All right, in fact, let me just write this nicely. Boys and girls. Now remember, when you're selecting the first team, you have 8 boys to choose from, and you're going to choose 4. And when you're selecting the second team, which should contain girls only, so you have 6 girls to choose from, and again you're going to be selecting 4. So let's work this out. 8C4 times 8C4 times 6C4. So that turns out to be 1050, which is again correct answer. Okay, so that's one question. Let's move to the next question. And here's question number 3, and this is from May, June 2016, paper 2, variant 2. Okay, so it's question number 3 that we're interested in. Let's see how this works. A team of 3 people is to be selected from 7 women and 6 men. Find the number of different teams that could be selected if there must be more women than men on the team. Okay, so questions like these, you can't have a head-on approach with questions like these. You need to consider all the ways in which you can satisfy the condition that's given to you. Okay, the condition is that there must be more women than men. Okay, so women and men. Let's see in how many ways we can do that. Okay, in fact, what I'll do is I'll make this line right here a dotted line. Not that it makes a difference, but it just looks nicer. Okay, yeah. So remember, you're selecting 3 people from 7 women and 6 men. So I'll write 7 here and write 6 here so that I know exactly the number of people I have to choose from. So one possibility could be that all 3 of them happen to be women and you're selecting essentially no men. Okay, so let's see how that works. So 7C3, so that's equal to 35. Now remember, there's one thing I'd like to mention here. Whenever there are several ways of satisfying the same condition or the same restriction, you work out all the ways they can be done and then you sum them up. Okay, so here's what I mean. Now one way is having 3 women, and no men. The other could be having 2 women and 1 man. And could there be a third? No, there couldn't be. There can't be a third possibility. So in how many ways can you choose 2 men out of 7? 7C2. And how many ways can you choose 6 men out of 6? Oh, sorry, 1 man out of 6. So that's 1. Sorry about that. So let's work this out. 7C2 times 6C1. So this turns out to be 126. Let's sum them up. 126 plus 35. So we get 161, which is the correct answer. Okay, so now we move on to the last question of this video, and questions like these are my absolute favorite, where you're making numbers, and especially when you have so many restrictions. And I'm going to show you how I personally prefer to solve questions like these. Okay, I personally prefer to spread them out. Okay, I'll show you what I mean, just bear with me. Okay, so here's question number 8, part A. It says a 5-digit number is to be formed from the 7 digits 1, 2, 3, 5, 6, 8, and 9. Each digit can only be used once in any 5-digit number. Okay, so let's highlight the word 5 digits so I know how many digits I need to use. And how many do we have total? Okay, so let's just highlight 7. Each digit can only be used once. Okay, we'll keep that in mind. So if there are no restrictions, so again, since you're making numbers, let's say 321 is not the same as 123, so that means you're going to be using permutation. So for the first part, again, it's going to be a no-brainer, 7p5, because you're arranging 5 out of 7. So 7p5 is equals to 2520, which is the correct answer. The number is divisible by 5. All right, so this is the point where things get interesting. So if the number is divisible by 5, what is the one thing you need to keep in mind? You need to keep in mind that the last number should be either 5 or 0. Now since we don't have 0, sorry about that, we're not going to place 0 here. Okay, so if the number needs to be divisible by 5, so that means the last digit needs to be 5. So how many options do we have for the last digit? We just have 1. Now for the remaining 4, now remember we had 7 digits to work with. Now one of them is gone, and that means now we're left with 6, but we're not selecting 5 anymore, we're just selecting 4. So that can be done 6p4 number of ways. So this turns out to be 6p4 times 1. So let's work this out. 6p4, so that's equal to 360. Okay, now the number is greater than 60,000. All right, so if the number needs to be greater than 60,000, that's the condition we need to settle first. Yeah, so remember, if there's a restriction or a condition, that is the condition that needs to be settled first. So 1, 2, 3, 4, 5. Yeah. So if the number is greater than 60,000, that means the first digit can either be 6, 8, or 9. So how many options do we have? We have 3 options to play with. So 3 here. And we had 7 digits to begin with. Now one of the 7 is going to take the first place. Okay, so that means now we have 6 to work with. And how many do we need from the 6? We need 4. So that is equal to 6. That can be done 6p4 number of ways. So 3 into 6p4. Let's work this out. 6p4 times 3. So that's equal to 1080. Okay, now we come to the fourth part of this, and this is where things will get really tricky. Okay, now I'll tell you what I mean by that. Now the first problem here is, thing is, we can't satisfy both these conditions at once. Okay, now I'll tell you why that is. I'll tell you why we can't do that. The reason why we can't do that is because if you want to make sure that the number is even, so that means you can have 2, 4, actually there's no 4, you can have 2, 6, or 8 as your units digit. Okay, that is what will make sure that the number is even. And you can have 6, 8, and 9 as the first digit. Now the problem here is, the reason why we can't do it like this is because you can see that you have 6 and 8 as your potential numbers in the first place, and you have 6 and 8 as your potential numbers in the second place also. So we can't do that. So instead, my approach towards questions like these is that you do it one by one. Okay, I'll tell you what I mean. So what I'm going to do here is, let me just copy this so I don't have to make this again. Yeah. So what I'm going to do here is I'm going to fix 2 as my last digit. Okay, so that means I just have one digit towards the very end. Now we had 7 digits to work with. Now one of them is gone. That means we're left with 6. But you can't do 6 before because there's another condition. And that condition is that the number needs to be greater than 60,000. So let's settle that condition also. So if the number needs to be greater than 60,000, how many options do we have for the first digit? We have 6, 8, and 9. Okay, there's no conflict here. 6, 8, and 9 is a different set. 2 is a different set, so nothing to worry about. So that means we have how many options? We have 3 options. Now we had 7 numbers to work with. 2 of them are gone. That means now we have 5, and we need to arrange 3 out of those 5. So that can be done 5p3 number of ways. So 3 into 5p3 times 1. Let's see what that is equal to. 3 into 5p3 times 1, so that's equal to 180. Right, now this is not the end, okay? Now remember, we just considered one possibility, okay? We need to consider more, as all the possibilities there are. Okay, so now what I'm going to do is, instead of fixing 2 as the last digit, I'm going to fix, what other option do we have? I'm going to fix 6, okay? Now if I fix 6, again, that means I just have one digit towards the very end. And for the first place, what do I have? I don't have 6 anymore, but I do, however, have 8 and 9. So 8 and 9. So that means now I have 2 options. And for the remaining 3, again, we had 7 to begin with. Now 2 of them are gone, so that means we're left with 5. And we have room for 3. So 5p3. So 2 times 5p3 times 1. So that's equal to, let me write this down, 2 times 5p3 times 1. So that's equal to 120. Okay, now we're at the home stretch. Okay, so this time, what is the number that I'm going to fix as my units digit? It's 8. Okay, because that's the only number that I'm left with, which when fixed as the units digit will make the number even. So for the first digit, that means we have 6 and 9 to work with. So that means we have 2 options. And again, for the remaining 3, we have 5p3. This is just a repetition of the previous condition. So 2 times 5p3 times 1. So that's also going to give us 120. Now let's sum them up. 120 times plus 120 plus 180 is equal to what? Is equals to 420. And that is the correct answer. So yeah, this is basically questions like these. I like to call them as a conflict question. Okay, now the reason why I call them a conflict question is because the numbers that you're using as the units digit can also be used as the first digit also. So that means there's a conflict. Okay, so when you have a conflict situation, this is my personal preferred method. Okay, if you have any better approach towards it, let me know in the comment section. I'll be more than happy to go over it. Okay, now here's part B. This shouldn't be too hard. Let's see. It says Ranjit has 25 friends, of whom 15 are boys and 10 are girls. Ranjit wishes to hold a birthday party but can only invite 7 friends. Find the number of different ways these 7 friends can be selected. So we're making sort of like a team, okay, if there are no restrictions. Okay, so that means if he wants to select 7 out of 25 and there are no restrictions, so it's just going to be 25C7. Let's break this out. 25C7, that's equal to 480,700, and that is the correct answer. Only 2 of the 7 friends are boys. Okay, so that means he needs to have 2 boys, okay, and the remaining 5 need to be girls. Okay, so here's how this works. So how many boys are there in total? 15. Okay, so he needs to make sure that he's just inviting 2 boys, okay, and the remaining 5 out of 7 are girls. So how many ways can you select 5 girls out of 10? So that's going to be 10C5. So let's work this out. 15C2 times 10C5. So that's equal to 26,460, which is the correct answer. 26,460. Okay. The 25 friends include a boy and a sister who cannot be separated. Okay, questions like these are interesting. Okay, that means either you're going to invite both of them, okay, or you're going to invite none of them. Okay, now, and this is a 3-mark question, so you got to make sure that you earn those 3 marks. So let's consider one scenario where both are invited. Okay, Now remember, when it says cannot be separated, doesn't necessarily mean that they have to be at that particular event or situation, whatever that is, or they have to be selected. It means that either if they're selected, both of them are going to be selected, or if they're not selected, if one is not selected, the other is also not going to be selected. So if both are invited, that means he doesn't need to worry about all 7 of them anymore. He just needs to worry about the remaining 5, okay? And that means that he's not selecting from 15 boys, because remember, 1 is coming for sure, so that means there are 14 to choose from as far as the boys are concerned, okay? And as far as the number of girls are concerned, the number of girls are 10. Now 1 is going to be there for sure, so that means there are just 9 to choose from, okay? Now, in how many ways can this be done? So 14 plus 9 is equal to what? 14 plus 9, I don't need a calculator for that, but yeah, 23. So that means now he has 23 to choose from. And how many is he going to invite? He's just going to invite 5 of them, okay? I mean, he's just going to choose 5 of them, because 2, like I said, are already taken into consideration. So 23 C5, so that's equal to 33,649. Now this is when both of them are invited, okay? So they're in the pool for sure. Now what happens if both are not invited? Okay, I'll do that over here. Both are not invited. In that case, he's going to exclude that boy and that girl from the pool of 15. So that means now he has 14 to choose from, and he has 14 boys and 9 girls to choose from. Why? Because both of them are not invited, okay? So 14 and 9 is equal to 23. So that means now he's selecting from 23, but he's selecting how many? He's selecting 7. Now the reason that is because we need to make sure that the 2 are not included, okay? So we're going to remove them from the people that we're choosing from, okay? So from the 15 boys, I'm going to remove that particular brother, and from the 10 girls, I'm going to remove that particular sister. So that way they cannot be separated, okay? So that means that way both of them are not going to be invited. So let's work this out. 23C7, so that's equal to 245,157. So total is equal to 245,157 plus 33,649. So let's work this out. 33,649. So that is equal to 278,806, which is the correct answer. Okay. So I hope these questions were understood by all of you. And again, if there are more questions that you want me to solve, so let me know. You can leave a comment, or you can reach out to me on Instagram, whatever you like. So like I said, that's all for this video. See you guys in the next one with more questions. So until then, take care. Bye bye.